Welcome guys, again we are taking you into adventure of soil development and soil maturing process. And as we take you through that process, we are also showing you cases, particular cases of soil degradation, soils which is on the verge of dying, soil that some years back was productive and now was not productive. It said that around 70 years back, these gullies here, which have formed into river channels, they were not there. If you look at it, there is no water flowing here. Basically, this was a flat land. But someone can ask, ask him or herself, what might be the cause of all this? Now, to just give you a suffice of reasons of why we see all these things is an interplay of many factors. Basically, we have the soil properties, the inherent soil properties. When you add that to anthropogenic activities, this is the human activities, what humans do to contribute towards catalyzing the process of soil degradation. This is what really happens. So humans play around 70% of the roles of degradation, and then other natural factors do the rest of the work. So basically, if you start it, nature will finish it for you. So they started doing the deforestation and controlled overgrazing. There are no intervention where gullies were being formed some years back, and all that led to this. Now, as my cameraman can show you now, I want to take you to what soil properties can really influence the degradation process. If you look at this one here, you find that there is a hill of a soil that was there previously, and in spite of the degradation processes that happened, it remained in the same position, undergoing very slow degradation compared to others. Now, you might ask yourself, what might have caused all this degradation and just one part of the land remained? This is now what we call the clay and soil properties. Now, you find that the clay that is within this mount here is the clay that is less erodible, okay? But these other clays here, they are the clays that are easily dispersed by water. And on top of it being dispersed by water, we are in drylands. And it being drylands, we know that majority of soils in drylands are of saline or sodic nature, meaning that we have a higher content of sodium compared to calcium and magnesium ratio. So when we have the sodium having a higher value compared to calcium and magnesium, you find that these soils are easily dispersed. Okay? Now, adding that to the kind of nature that is not stable, you see this ecosystem has been interfered with. So it is not stable to the point that it can withstand those erodibility factors despite the soil being weak. Now, imagine you have a weak soil and you have factors that accelerate this erosion. What happens? This is what happens now. When you see now, you see a huge erosion that has led to deep gullies. If you compare with human beings, I'm almost 1.67 meters. But when you look at this one here, is almost not less than, this is not less than 30 meters deep. It is not about anything else. This is just 70 years of erosion that has caused this 30 meter of soil going away. Now, where does this soil go? You might like, this soil is not important. If it goes, it is a natural process. Okay, that is a natural process. But let's look at the dynamics that are involved in this process. One thing that we are losing is that we are losing the physical soil. That this soil is not supposed to move to another ecosystem, but because of these factors we've talked about, they have moved. Okay, now remember that soil is a stock, is a stock of many other many other nutrients. Like we have other soil fertility nutrients, but the most important one is that soil is the stock of carbon. So if soil is the stock of carbon, which terrestrially there is no other system that is much better than soil, if we lose this, we open the soil, we open the carbon that is sequestrated within this structure here to one, is that it will be easily oxidizable. And if it is like oxidizable, it will change to methane. And if it changes to methane and carbon dioxide, it will contribute to greenhouse greenhouse gases. So that is methane and carbon dioxide. Now, besides that, the particulate carbons that are bound within the soil will start moving. Where will it move? It will move to aquatic ecosystems. So we will be polluting aquatic ecosystem and even raising the riverbed or the aquatic system to the level that fish and other marine faunas cannot survive. Are you ready to kill other ecosystem because of your activities? Why don't we change? Why don't we do research? If you have money, you are an organization, why don't you fund these to create the solutions we are creating? Currently, we have kilometers of terraces built across the landscape, and also we have got sand dams that we have built to make sure that instead of us restoring, because the term is to restore, which is impossible to restore this to what has happened over 70 years, but we can try to rehabilitate the system to at least adjust, not really to the best, but to the current, to the more state that limits or mitigates further further degradation. So out there, any sponsors, any environment enthusiasts, we ask you, this is a menace that has been created over a period of time, but we as young and people who are ready to work for our future generations, why not do this? And before you do that, the first thing you can do is to click that button and like that video. Let it go wide, let it go global, let everyone see that we are here to ensure that we get the change, and the change that our generations will love. Be the change. Click that button. Be the change. Sponsors, be the change. Look for us. Let's work together. Let's collaborate. Thank you very much.